Doctors know that certain drugs can turn off your consciousness like a light switch. But here's what they just discovered. Those same molecules also dampen specific quantum effects inside your neurons. That's not a coincidence, it's a clue. And when you see what happens at 6.6 nanometers, the whole picture shifts. Hold that thought. If consciousness depends on quantum events in the brain, then free will isn't about escaping physics. It's about tuning it. And you might be doing it right now without realizing. Which means this isn't just philosophy, it's practical. By the end, you'll know how to tune better. How to set conditions where your intentions have more influence. How to bridge the gap between who you want to be and what you actually do. To see where free will could live, we need to understand the trap it's stuck in. Okay, so basically, free will sits between two cliffs. On one side is determinism, every atom's motion fixed by the past. On the other side is randomness, events flicker without rhyme or reason. Both erase agency. If every choice is inevitable, you're a spectator. If every choice is random, you're noise. Either way, the you that deliberates, values and intends seems to vanish. Picture this, you're standing in line at a coffee shop. Someone cuts in front of you. You feel anger rise. Do you say something or stay quiet? In the determinist view, that decision was already locked in at the Big Bang. Every atom in your brain already knew what you'd do. In the random view, a quantum coin flip decided it, and you were never consulted. Both feel wrong because neither includes the person weighing options. Here's an old idea called Laplace's demon. Imagine a super being that knows where every atom is and how it moves. That being could predict everything, including your next thought. In that world, your brain is just atoms following rules. No surprises. No could have been different. It's neat. It's also crushing. So naturally, people look for exits. Chaos theory sounds like one. Sensitive dependence, unpredictability. Maybe there's wiggle room there. Here's what people get wrong. Chaos isn't freedom. Chaotic systems still follow rules. They're just super sensitive to tiny changes. A butterfly flaps its wings and a hurricane forms a month later. Weather does this. Dripping faucets do this. Even planets do this. But being sensitive doesn't give you choice. It just makes the future hard to predict. The causes are still there, we just can't track them all. That's why physicists and philosophers turn to quantum mechanics. If determinism is too tight and chaos is just hidden determinism, maybe quantum randomness offers something different. Here's the weird part. Quantum mechanics trades certainties for probabilities. Electrons don't have one definite outcome. They have possible outcomes until something happens. Classic experiments show this. Measure an electron's spin and you get one of a few results. But you can't predict which one. And there's a deeper rule, one that sounds like a limitation but is actually a feature of reality itself. You can never know both where a particle is and how fast it's moving with perfect accuracy. It's not a measurement problem. It's built into reality. But randomness isn't agency. If a neural event hinges on a quantum coin flip, that flip didn't consult your values. It's not the kind of I chose we care about. So the dilemma is sharp. Determinism gives us lawful order without freedom. Quantum indeterminism gives us wiggle without will. Neither alone explains how intention matters. Okay, pause. If you're feeling the weight of this, good. It means you're tracking the trap. Determinism crushes agency. Chaos just hides the chains. And now we're about to add quantum mechanics to the mix, which sounds like it should save us, but actually makes the problem worse. At least at first. Have you felt that? The sense that you are choosing, but you can't quite explain how if everything's just atoms. Drop a comment if that disconnect bothers you. I want to know I'm not alone here. So here we are, trapped between a universe that runs like clockwork and a universe that flickers like static. Neither one has room for you. Unless, what if agency isn't about escaping these layers? It's about existing between them. What if you isn't one thing at one level, but a process that bridges levels? That's where everything clicked for me. The question isn't, does the brain use quantum mechanics anymore? It's, can the brain harness quantum events in a way that's neither strictly predetermined nor purely random? Can biology tune randomness into agency? If so, free will could live in the interface, where lawful biological structure shapes which quantum possibilities become actual, and those actualizations shape the next classical state. That's a bridge between levels, not an escape from physics. At the neuron network level, goals, attention, and context exist as patterns. For decades, philosophers found a middle path, compatibilism. It says freedom is choosing in line with who you are, within lawful constraints. Sounds reasonable, right? But there's a problem standard compatibilism can't escape. It lives entirely in classical dynamics. It doesn't add new causal input, it reframes old inputs. Which brings us to the core question. Can the brain harness quantum events in a way that's neither strictly predetermined nor purely random? If so, free will could live in the interface, where lawful biological structure shapes which quantum possibilities become actual, and those actualizations shape the next classical state. That's a bridge between levels, not an escape from physics. Here's why this matters to you personally. If determinism is right, every regret you have is pointless. You couldn't have done otherwise. If randomness is right, every achievement you're proud of was luck. You can't take credit. Both rob you of authorship. But if there's a third option, if you can influence outcomes without controlling them absolutely, then responsibility makes sense, growth makes sense, and effort makes sense. Your life isn't written. It's not random. It's tunable. This is where or enters, a third lane that reframes the whole question. Not clockwork. Not dice. A structured process where biology shapes quantum collapse and collapse shapes mind. Time to unpack that. Let's break that down. Orr says a conscious moment isn't just neurons firing. It goes deeper, inside the neuron, past the membrane, into the cell's internal scaffolding. There's a structure there most people have never heard of, and it might be where consciousness actually happens. They're called microtubules. Think of microtubules as tiny structured cylinders built from repeating proteins. If you could shrink down and walk inside one, you'd see a lattice, like a scaffolding tunnel made of hexagonal rings, vibrating with electrical patterns. 25 nanometers wide. That's about 1/30,000th the width of a human hair. Thousands of them run through each neuron, forming a dynamic network inside the cell. They aren't just struts, they host electrical vibrations and organized patterns. In Orr, those patterns support quantum states that can exist in superposition for brief windows, even in the warm, wet brain. Now, what's Orr objective reduction? This is the part that separates Orr from every other quantum consciousness theory. It's what makes the process lawful instead of random. Here's the simple version. A quantum state can exist in multiple possibilities at once. But when the difference between those possibilities gets big enough, the universe forces a choice. The state collapses into one real outcome. Not because someone observed it, because reality itself can't hold both options anymore. It's like a rope under too much tension. It snaps. That's huge. It means collapses happen whether we're watching or not. They're real events, not artifacts of observation. But here's where it gets even more interesting. The orchestrated part is the biology. The brain isn't passively waiting for random collapses. It's tuning conditions so those collapses happen at useful times and in useful directions. Here's the weird part. That means the brain could bias which quantum alternatives become actual within lawful limits. Not by breaking physics, but by shaping the context, ionic conditions, lattice resonance, timing of neural synchrony, so the reduction feeds forward into neural firing patterns that matter. In other words, your neural state doesn't just await the next collapse. It negotiates with it. Timing is central. Or links conscious frames to collapse events clustering around tens of milliseconds, roughly the rhythms where we feel continuity, notice change, and integrate senses. That's the tempo of perception flicker, attention shifts, and moment-to-moment awareness. The simple version is, classical networks set up a stage. Microtubule states build quantum tension. Objective reduction resolves it. The result pushes the next round of network activity. Frame after frame, you get the movie of consciousness. I know what you might be thinking. This sounds like science fiction. It did to me too. Quantum effects in the warm, wet brain? For decades, physicists said impossible. Decoherence, quantum states falling apart, happens in picoseconds at body temperature. Game over. Except biology doesn't care what physicists assumed. Proponents counter that microtubule structure, ordered water layers, and collective resonances may extend coherence just long enough to matter, and that biology may actively support these windows. Recent work in quantum biology makes the general idea less far-fetched. But it's not proof that or runs your mind. That's what the evidence section is for. Here's the best way I've found to picture this. Once you see it, the whole mechanism clicks into place. Imagine you're driving through mountains at dusk. Static fills the car. You adjust the dial slowly, 66.3, 66.5, 66.7, and suddenly a station locks in. Clear voice, clean signal. You didn't create the broadcast. You found the frequency where signal and receiver aligned. Your classical brain is that slow turn of the dial, setting the band, filtering noise, stabilizing rhythms. Microtubules are the antenna, sensitive to specific frequencies. When everything aligns, a conscious moment locks in. Does that radio metaphor land for you, or does it feel like a stretch? I'm genuinely curious. Some people find it clicks everything into place. Others think I'm oversimplifying. Tell me which camp you're in. The song isn't imposed from outside. It's the lawful emergence of a coherent signal out of many possibilities. In that light, a conscious moment is the station coming into clarity as a particular set of quantum possibilities collapses into one broadcast that the rest of the brain can amplify. Why does this matter for free will? Deterministic physics alone gives you a closed script, every choice already written. Pure randomness gives you noise, every choice meaningless. OR adds something different, a lawful but non-computable input. That word, non-computable, is doing a lot of work. It's the key to why this isn't just determinism in disguise. Non-computable means each collapse carries information that can't be fully predicted from what came before. Not random. Not predetermined. Fresh. Your choices remain constrained by who you are, your history, your values, your neural patterns. But they're not fully entailed by the past. There's room for something new to enter the process at each conscious moment. Agency could ride that edge, where tuned biological structures meet objective reduction, and both shape what happens next. Let's also clarify scope. This isn't mind over physics, it's mind as physics plus a quantum layer. The brain remains a physical system, obeying laws. The claim is that within those laws, there's a built-in mechanism, objective reduction, that injects a different kind of causation at precise times, and that biology has evolved to harness it. That's the promise, not magic, but a richer physics of mind. And it sets up a testable question. Does biology actually tune those collapses? If it does, here's what becomes possible. You could learn to stabilize the conditions where better choices emerge. You could recognize when you're drifting and course correct in real time. You could train attention the way athletes train muscles, because attention shapes which quantum possibilities become your next thought, your next action, your next habit. Time to find out.